Good day, students. Chauke Emmanuel here, and today I have a very lovely paper that was written few hours ago by first year's class of 2024 in Sifako Makato Health Science University, and that is SMU. Speaking from the advantage point, I think many students were swimming and fishing in a dirty pond just for the benefit of breaking a glass ceiling, precisely because this was a well-oiled paper, and for that prudent, allow me to treat all the theorems as a white elephant and do only applications. Guys, I've been away for some time here on TikTok and also on YouTube, but I'm back now, guys, and this paper was written just a few hours ago. Guys, don't forget to subscribe to this YouTube channel and also in my TikTok account. If you are watching it from the TikTok, just follow. Okay, and that is Inimitable Academy. Let's do this paper, guys, and see how far we can go with this. They said to you guys, determine the following limits. You are given the trigonometric limits right there. Okay, so let me do this particular question. I'm gonna start with let me check something here. Okay, so you only have two questions. Okay, so I'm gonna have question one. I'm just gonna pen everything down. Question one, guys, let's check. Number one, you have two things happening there, okay, which is to evaluate or determine rather the limits of the following. So the limit as x goes to 0 of a sine x, of a sine 6x over sine 2x. Let's check that. Number A, we have got the limit as x goes to 0 of what now? Of sine 6x divided by sine of 2x. We want to evaluate, guys, or determine this limit rather. So it's not bad. I'm going to take this 0 and plug it here in every position of x. So I'm going to get 0 over 0 because sine 0 is 0. And also here, that is 0 over 0. That means you need to simplify these trig limits. Let's check how you guys will do this. You will then say that that is equals to the limit as x goes to 0. You need to rewrite this in a special way, and that is to say that you have a sine of 6x over 6x. You need to multiply this by the quotient of that particular coefficient of the trig ratio, and that is 6x. Divide this by 2x, multiply by 2x over sine of 2x. Let's check now, guys. This whole stuff is the same as this problem. How? Pay attention. This cancel with that, and then this cancel with that. So you basically have this over that one, which is basically the same problem that was provided. And then now you need to take the limit of the product. All right. So basically what I've written here was just to rewrite the problem, but not changing the formality of the given problem. And from the best of my mind, this you will then say that is the limit as x goes to 0 of what, guys? Of sine of 6x over 6x multiplied by, remember that the limit of the product is equals to the product of the limit. And that is precisely the limit as x goes to 0 of 6x over 2x multiplied by the limit as x goes to 0 of 2x over sine of 2x, just like that. All right. Now we know of this, the very popular rule to say that is going to give you 1. That limit is going to be 1, all right, because the sine of the angle over the angle itself, that is going to give you guys 1 in the trigonometric limits. Now you have multiplied by pay attention, the limit as x goes to 0 of this you can simplify it. Hey, you can see that the x will take away this x here, and then this 6 it will be 2 now, because that is 6 over 2. All right, and then you are now left with a young 3 there, and then multiply by the limit of 2x over sine of the very same quantity of 2x, and that is 1. All right, that is going to give you 1. And then now you will then say that this is the limit of a constant, which is a constant. Therefore, you've got the 1 multiplied by, that will be 3. Beautiful people. Multiply by 1, and then the answer is a young 3. If you multiply 1 multiply by 3 multiply by 1, that is going to give you guys 3. I think this is a very basic stuff. Everyone can do that, right? So the answer was 3. How many marks was this? This was 4 marks. Okay, so they will see where they give you guys the marks there. Now the B part of it, you have got the limit as x goes to, let's check the approach and the function. That was going to 0 of 1, take away cos x over sine x. Okay, let's do that. That is 0 of 1, that is 1 minus a cos of x, divide this by a sine of x. Very straightforward. Now pay attention. That is going to be equals to, now first thing first, check this in every position of x. So if you take a 0 and you plug it here, the cos of 0, that guys is going to give you a 1. So 1 minus 0 there, that is a young 0, over a sine of 0, that is a 0. There's no doubt of that. So you have a 0 over 0. That means this must be simplified. All right, so I'm going to rationalize the numerator in this case to say that is going to be the limit as x goes to 0. Look at that. You want to rationalize what, guys? The numerator. That is going to be cos x over sine x. I'm just going to multiply this by the conjugate of the rationalization of the numerator, and that is 1 plus a cos of x over 1 plus, guys, a cos of x. We call these guys a conjugate, a trig conjugate. And then you guys have now the limit as x goes to 0. Think about it. The signs that you rationalize would always give you guys what, a perfect, a difference of 2 squares. So this multiplied by this is the difference of 2 squares. You precisely have 1 minus what, a cos squared of x, and then now you have a sine of 1 plus a cos of x, just like that. I want you guys to be very careful here. You now have the limit as x goes to 0. Now in the numerator, you have a square identity that was largely taught in your grade 11 classes. Okay, we call these guys a square identity, and that is a sine squared of x. All right, you get a sine squared of x, or you can say it's sine times sine. All right, I just forgot the x there in my denominator for sine. Allow me to space them, and then I put my x there. Okay, so now this is equals to, this is over sine x multiplied by 1 plus a cos of x, just like that. You guys have this for now, and I don't think that is a difficult thing. Let's check now. You have got the limit as this goes to 0. Pay attention. The square will take away the whole of sine there. So you precisely have a sine of x there over 1 plus a cos of x. Now that you are done with the simplification, you can now check the existence of the limit. You check if the limit does exist. So that means you're going to take this 0 and put it in every position of x in that particular function. So you're going to have a sine of 0 over 1 plus a cos of 0. And then as a result, you guys are going to get a 0 over 1 plus 1. And then you've got a 0 over 2. So because 0 over 2 is going to give you guys a real number, and then the answer will be a 0. So here the limit was 0, the answer for this. Okay, the answer, guys, was 0 for that limit, and then for the previous one the answer was a positive 3. Okay, that's how you guys will really do the first two questions on limit. Now, I want us to really do the next questions. I don't think it was really bad. Okay. So now let's go on to the other questions. I did say that I'm going to treat the theorems as what? As a white elephant. By that, I mean I won't be able to do that. I will do it in my part 2. So now I want to do the application, and then part 2, I do the theorems. Okay. So now I'm going to do that. It's an application. And then that is a theorem. This one is a theorem, and that's a chain rule theorem. Okay. So I'll prove that in the second part. Now let's prove that question. That is question 2. Let's check, guys. Question 2. I'm just gonna pen this, guys. That is question 2. Well, it's still question 1, but it's 1.3. Sorry about that, guys. That is 1.3. They say if f at x is equals to a cos of x, then we need to find, guys, f prime at x. I want to find that, so I'm going to say that the first derivative is going to be given by the limit as h tend to 0, guys, of what? Of f of x plus h, take away f of x like that. You divide these guys by h. Okay, that is called the first principle, and you prove every theorem with this particular formula. And then now, this is a very popular stuff. That is the limit as h goes to 0 now of cos of x. So x now becomes x plus h. All right. That is x plus h minus the function itself, which is a cos x, over h. That is over h. And then now I'm going to say that that is the limit as h tend to 0 of what? In the numerator, you can do that. If you observe this, if you guys observe this part here, we call that a compound angle identities in your high school. So let's try and expand it. That is going to be a cos of x multiplied by a cos of h, because here it's plus, remember it's a plus h there. This is a plus h, guys. Okay. So that now it becomes what? It becomes a negative there of what? Of sine x multiplied by a sine of h there. There's a minus cos of x there, sitting comfortably in the numerator. And then this must be, guys, divided by h in that order. So you're going to say to yourself, that is equals to the limit as h tend to 0. Think about it. You're going to have h here. There are like terms. Now, what are the like terms, Prof? This has a term of cos x. And then this also has a term of what, guys? Of cos x. So now I'm going to group those because those are like terms. I'm going to have a cos of x multiplied by a cos of h minus a cos of x there. And I still have a minus of sine x multiplied by a sine of h. You guys need to have that. So you can see that this is going to be one term, and you can break that nicely to say that is the limit as h tend to 0 of this is one term divided by h. Okay, so you're going to have a cos of x multiplied by a cos of h minus cos of x, divide this by h minus the other term, which is a sine x multiplied by a sine of h, divide this by a common denominator of h. Okay, and then now you can take the difference of the limit, which is going to be the limit of the difference. But cos is common here, so you can take it out, that cos. So if you take it out, you're going to have a cos x there, and then now you have a limit as h tend to 0 of this minus 1. Okay, So that is going to be a cos of h minus 1 over h minus, here you can see that you have a sine h over h, and then therefore this becomes a constant, and then you're going to have a sine x multiplied by the limit as h tend to 0 of what, guys? Of sine h over h, just like that. I want you guys to be very careful in this step, right? So you have a cos of x multiplied by the limit value of this. That has a value in the trig limits, and that value is 0. I did prove this to my students, okay? That is 0. And then now you have a minus sine x there multiplied by, pay attention here, this also has a value in limit. Okay, what is the value of that limit? That is 1. I'm trying to circle that, it is misbehaving. So now that is a value of 1 in that order. So therefore, that is going to give you guys 0. This is 0. And then a minus sine of x. So 0 minus sine x, you guys get a negative sine x. Okay, so that is the derivative of cos. It's going to give you guys, let me switch off the heater there, it's a bit hot. Okay, so you guys get that as the first derivative. You get a negative sine x for that. That's how you guys will do 1.3. I don't think that was a bit complex. And then if you have any question, you can comment on the section below. Now, let us look at question 2 now. The first question 2 was to really prove that it's a chain rule. It's a very interesting theorem, of which I'll prove that in my next session together with 1.2 and 2.5. Okay, because these are theorems. Now, question 2, let's do it together. Question 2, guys. So in question 2, they say find dy by dx, or determine, differentiate the following rather. Let's go and read that particular question. Where is it? They say to you guys, differentiate the following. You have f at x, which is given by the square root of 3x plus 1 over 2x plus 5. So let's get that derivative. So that is Roman figure 1 there. We have f of x that is given as the square root of what, guys? You have a 3x plus 1 over, this is 2x plus 1. I advise students that when you do derivatives and also when you do limits or integrals, you need to remove this square root and write that as a power form. So therefore, this particular function f at x, it can be written as what? As this to the power 1 over 2 of 3x plus 1 over 2x plus 1. Now you can take that derivative, right? So now the derivative of this, we are going to use, guys, a chain rule, of which they ask you to prove that. So now if you use the chain rule, you're going to drive the outside power function, which is a half there. So you're going to bring that power half there. You bring it down into, you keep what is inside. And that is a 3x plus 1 over 2x, and then plus 1. You take away 1 from the power, and that is going to leave you guys with a negative 1 over 2 multiplied by the derivative of the inside part. So now you need to drive this part. You now need to differentiate that. It's not bad there. We are going to use what? We are going to use a quotient rule. So you guys get 1 over 2 into 3x plus 1 over 2x. I think this one's plus 5, if I'm not mistaken. That is 2x plus 5. So I made a blunder there, but it won't really affect us that much. So that one there is 5. And then this one here, guys, is 5. And then I'm only seeing it now. So let me change it. So So this is 5, and then that is 5. You're going to put a plus 5 there, and then to the power negative 1 over 2. Now, you need to multiply by the derivative of this part. So, that derivative is very interesting. It's a quotient rule. You guys need to square the denominator there. That is a 2x plus 5. You differentiate the numerator. That is going to be 3, while you're keeping what? Your denominator. And that is 2x plus 5. Minus, now you keep the numerator while driving the denominator. And that is 2 multiplied by 3x. And then a plus 1. So that is your answer there. You don't need to simplify it, okay? Unless if you have time, you can simplify that by saying that this multiplied by that is 6x minus 6x. So the answer is 0 for the x. And then now this will be 15 minus 2. So it's going to be now 13. All right, so that is if you want to simplify that. Let me do it for you and say that will be, let's really do it like this. We just need to copy this part because we can't simplify that part. We can, but there's no time for that, right? And then you simplify this, you guys got negative 13. That is if you want to do that. So it's 15 take away 2. So 15 take away 2, guys, you don't even need a calculator, is 13. But should be positive 13. Okay, so that should be positive 13. Be very careful on that. So now that's how you guys will do that particular question. Now let me do the next derivative. I didn't really see that. So that is the natural log of a natural log of the x cubed. All right, let's do that. Roman figure 2. We're almost done, guys. We have Roman figure 2 now. You guys have f at x. That is equals to the natural log of the natural log of x cubed there. Now to do this will be very straightforward. It will be the first derivative, which is going to be equals to, when you derive that, you first derive the outside one, right? Which is 1 over what is inside, which is this part here. And that is a natural log of x cubed multiplied by the derivative of what is inside. So what is inside is a chain rule again. So you're going to say that is multiplied by 1 over x cubed. Okay, you now need to multiply by the derivative of x cubed. And that precisely, guys, gives you what? That gives you 3x squared. You can leave your answer like this, or you can leave your answer like this. This would be 3x squared over, that should be x cubed, the natural log of what? Of x cubed. So that is the first derivative of that particular problem. Very straightforward. Is the chain rule there? And then Roman figure 3 now. You have f at x. Let's go check it quickly. That was what? That was everything to the power 2 there of an exponential function. To the exponent natural log of the tangent of 3x squared. So let's do that. It's not bad, eh? So you have everything to the exponent 2 of this. So that is going to be a natural log of the tangent of what, guys? Of 3x squared. You want to take the derivative of that. So this will be the first derivative, which is going to be equals to, I'm going to use the chain rule because that's a power function. So you bring it down, you're going to have a 2 there, and then you keep what is inside. That is e to the power and natural log of the tangent of 3x squared. And then you can put a 1 here, but it's not a must. Okay. Now you multiply this by the derivative of what is inside this part. If you derive that, it's going to be e. It's basically itself of the tangent of 3x squared, like that. Now you need to multiply by the derivative of the exponent. So because of space here, you can see I have a tiny space. Allow me to continue here. So this stuff here, I'm about to write it here because I have enough space here. The derivative of the exponent, that should be 1 over, think about it, that should be 1 over the quantity inside, which is the tangent of 3x squared, multiplied by the derivative of the inside there, which is going to be a secant squared of what? Of 3x squared there. You now multiply by the derivative of what is inside that tangent, which is going to be a 6x. So that is the answer there. That must be here. So this answer, you must put it here, guys. This whole stuff there. If you have enough space in your book, that is how you should have done it. But the derivative of the tangent is the secant squared of that angle. You now derive the angle, which in this case it's 6x, if you wish to derive 3x squared. All right. Now, let's check the next question while we have time. Now, that is the Roman figure number 4. Right. So that was y. Let's go check. Let's go check that. That is 6 marks, right? Y equals to the radicand of x plus the radicand of x plus the sine of a natural log of x. So let's pen that down and then do it as well. You guys have a very beautiful radicand there. Okay, you guys get x plus the radicand again of what? Of x. This is x. And a plus sine of a natural log of x, just like that. Okay, you guys have that. So for me to really do that nicely, I need to simplify this properly. Let me remove the square root, because the square roots normally, they traumatize us. Okay, so I'm going to put a power of 1 over 2 there. And then you guys have x there, plus the same stuff here, that is 1 over 2. So you guys have what? You guys have x plus sine of the natural log of x, just like that. So that is your y that you must take the derivative of. So if you differentiate y with respect to the variable of interest, and that is x there, you guys get dy by dx is equals to, it's a power function and a chain rule function. You drive the outside power, that is going to be 1 over 2 into, you guys keep x there, into x plus sine of the natural log of x there. All right, and then now you take away 1 from that power, it's going to give you -1. Think about it. And then now you multiply by the derivative of the inside that you have kept, and that is going to be 1 plus the derivative of this, and that is precisely 1 over 2 into, so you are keeping x plus the sine of the natural log of x there. You take away 1 from that is 1 over 2. Hey guys, now there's a multiplication that you must put here just after this term. So that multiplication is the derivative of that part. So I'm just going to put it just below that. The derivative of this is what must multiply that term. Be very careful there. And that is 1 plus the cos of that natural log of x multiplied by the derivative of the natural log, and that is 1 over x. Leave it like that. Don't simplify. I don't like it when students love to simplify these type of problems, but this multiplication should just multiply this term, and then you can close it with the blue, because this blue bracket here, it accommodates 1 plus this term, And that term must be multiplied by this fun stuff right there of 1 plus the cosine of the natural log of x multiplied by 1 over x. So I therefore wish to advise students not to simplify that particular quantity. Now, let us look at 2.3 and see what we are given there. So 2.3, let's go and check it. What are they saying there? 2.3, determine dy by dx if 1 over x plus 1 plus 1 over y plus 1. They give you guys 5 marks there. No, it's 5 marks. Yeah, it's 5 marks. Cool. So they give you that problem, beautiful people. I don't think it's bad. Let's try and do that. It's not really bad. These are application. So you guys have 1 over x plus 1, and then a plus 1 over y plus 1 is equals to 1. Guys, I'm looking at it. They give you guys 5 marks. So I can really, if I know the rules of derivative, I can do it in the brain that this would be like -1 over x plus 1 all squared. All right, but I'm looking at the marks. Is it worth it? Or I should just use a quotient rule. Same thing with this. The answer of that would be -1 over y plus 1 all squared multiplied by the derivative of the inside, which is going to be dy by dx. It's an implicit derivative, precisely. So this is 5 marks. I'm gonna do this in 2 ways. The longer way, which is worth the marks precisely, will be to derive this. So if I derive that, I'm gonna get x plus 1, and then I square this. And then I need to really derive that. That is 0 minus, so that is going to be 0 minus, because this 0 is going to be multiplying this, and that is 0. Multiply by, you now keep 1, you derive this part, that is going to be 1 if you derive x plus 1. All right. And then a plus, the same stuff that I've done here, I'm just going to do it here. That is y plus 1, and then I square this. I derive this. That is going to be 0 minus. Now, I keep the 1 there, multiplied by the derivative of this part. So the derivative of that is going to be dy by dx. Okay. That is equals to the derivative of a constant that is 0. So this means that you guys have a -1 over x plus 1, and then I square this, minus, I can say that is 1 over y plus 1, and then I square this, multiplied by dy by dx, because they are looking for that situation. All right. So what can I do now? I want to solve dy by dx. I can take this term to the other side. So this means I'm going to be left with 1 over y plus 1, and then I square this, multiply by dy by dx is equals to, that becomes the positive of that, which is going to be x plus 1, and then I square that. Okay, remember guys, I want to solve I want to find dy by dx. So that is to multiply now, or divide everything by that term. So I want to have that term as 1. So I'll say multiply by negative of y plus 1 all squared, both sides. Okay. So I'm multiplying this whole equation by the negative of that. So that will cancel with that. Okay. And then you will have, guys, dy by dx is equals to the negative. And then this multiplied by that. So that should be, guys, your y plus 1 all squared over x plus 1 all squared. That is the derivative of that. Or you can say that that should be y plus 1 over x plus 1, and then I square that. So that beautiful people leaves me with dy by dx. Okay, let me know in your comment section on how you guys tried this particular problem. It was a very interesting problem, I can tell, but I want to know how you guys approach this, because it looks like it's also a white elephant, but from the basis of my understanding, it was a doable problem. Okay, so let me know in your comment, okay, as to how you guys have approached this. It was a very straightforward question. Now, the next question, let's see why they are giving it, guys. They are giving it 8 marks. Let's go and check. I saw 8 marks there. They say, guys, that is 8 marks. Use logarithmic properties to differentiate the following. That is y equals to the natural log of cos squared of x over x to the 4th power multiplied by the square root of 3 sine 3x. So let's really work it out, guys. We're almost done. Just pay attention. Guys, they give you y is equals to natural log of the cos squared of x there. Now, pay attention. They say that is x to the 4th power, or to the exponent 4, multiplied by the square root, of sine 3x squared. They say find the derivative of that. Find the derivative of this using, guys, the logarithmic properties. So by that they mean that if you have a natural log of x over y, that is going to be a natural log of what? Of the numerator minus the natural log of the denominator, and that is y. And same thing with the logs itself. Now, pay attention. If you have the natural log of the product like x times y, that is the natural log of x plus the natural log of y. So they are talking about these two rules very heavily. So because now I have the numerator as the cos squared of x, so that will then mean that my natural log becomes this, a cos squared of x. Now, there is this quotient line here, which means division. I'm going to say a minus of the natural log of what? Of every quantity that is in the denominator. And that gives you guys x to the exponent 4 multiplied by the radicand of sine of 3x squared. That is the sine, guys, of 3x squared, like this. You must close your brackets in that order. Now, pay attention. This is another rule for product. So that gives you guys a natural log of a cos squared of x minus, that is going to be a natural log of x to the exponent 4 plus, be very careful here. This negative means this. So I'm going to have it like that. Just going to use a bracket like this. Okay, because this is something else. Be very careful on that. And then you have a natural log of the square root of what? Of sine of 3x squared. Now, before I differentiate it, think about it in this way, that you have a natural log of the cos. So the cos is the same as cos x, and then you square this, the same as cos squared x. think about it. And then a minus now, you have the natural log of x to the exponent 4. This is more like, remember it's plus a natural log. Look at that. That is the same as sine of 3x squared to the power 1 over 2 for that square root. And then you close that. Now, there's a very beautiful rule that I didn't give it to you here. And that states that if you have a natural log of x to the nth power, that is the same as the nth multiplied by the natural log of x. That is also one of the useful rule in this particular question. And I hope you know that law. So now this means by virtue of the properties, you know, that is going to give you guys 2 the natural log of the cos of x there. Now, allow me to really multiply everything by the negative and also applying the rules. So that's a negative. This is going to be 4 ln of x. So it's going to be 4 the natural log of x there. And then a minus. This multiplied by that is a negative. But I'm going to bring the power down. So that is a 1 over 2 the natural log of what? Of sine of 3x, like that. But it's a square for that 3x. So it is now and then that you can be able to find dy by dx of this. And it's going to be very interesting. Check how. Therefore, dy by dx is equals to, you keep the 2, you derive that. All right. So that becomes 2 into 1 over cos of x multiplied by the derivative of cos x. And that is negative sine x there. And then minus 4 multiplied by the derivative of a natural log. And that is 1 over x in that order. Minus, beautiful people, the derivative of this. And that's negative 1 over 2 multiplied by 1 over sine, guys, of 3x squared. Multiply by now the derivative of sine 3x squared. So that should possibly be 6x and then a cos of 3x squared. That is if you wish to derive that. And then if you want to simplify it, you'll say that sine over cos, that's going to be a tangent. So this should be negative 2 tangent of x, and then minus 4 over x. And then this part, the 2 will take away 3 there. So you're going to have negative, I guess that will be 3x in much of my understanding, over sine of 3x squared. And then pay attention here, there is a cos of 3x squared, and this is going to give you guys a cot of 3x squared, because the cos over a sine, so that's, let's just put that as a cot now. So that is a 3x multiplied by a cot of 3x squared. All right, that is the answer for dy by dx. I think this was worth the marks, okay? But if you didn't simplify it, they'll give you guys full marks for this, because in derivatives, we don't really advise students to simplify. And this is how best I would answer this question. The part 2, guys, is coming for theorems. Don't forget, guys, to subscribe to my channel and also my TikTok account. You must follow me there. All right. I do pass papers of different universities. Otherwise, thank you so much for watching. Keep subscribing. Danko.